And it does it by way of the intestines. Now, all of that's going to come back to us when we start talking about the chapter on blood. Our heart releases hormones. They're called natriuretic peptides. What is a peptide? Amino acids are made up of peptide bonds. Peptides are the peptide bond is what strings together amino acids. So if you only have that string of amino acids, it's just simply a peptide. If it's not into the shape of the protein, it's just the string of amino acids. So a stringing together of amino acids is a peptide. This one indicates a blood pressure going up. It'll get secreted, and then what it does increases sodium excretion, because water follows sodium. And if I can urinate off this sodium, I decrease the fluid level in the body, which decreases my blood pressure. In the case of the aldosterone acting on the kidneys, what did it do to the sodium level?
Increase.
It returned it, so that means it wanted to return it back to the body, because water follows sodium. I don't know how many times I'm going to have to say that. Water follows sodium, and therefore the water returned back to the body and raised blood pressure. Okay? So it's a little confusing, I know. Our kidneys, we have at least 3 hormones. Once again, for that use of the vitamin D. Took the skin, the liver, and the kidneys. The kidneys can convert calcidiol from the liver into calcitriol. That all started with the vitamin D that we consumed in our diet, and in the case of exposing ourselves to the sun, you know, making sure that we're getting the sun on our skin, we now have that hormone-like substance. So that's the part that the kidneys are going to do. Now look at this. They secrete renin. Part of my renin, angiotensin, aldosterone system to raise blood pressure. My raw system. So I've now shown that I have involved my adrenal gland, my liver, my lungs, and my kidneys. Renin will take the angiotensin to angiotensin 1, circulate it to the organs. When 1 gets to the lungs, because the lungs contain ACE, an angiotensin converting enzyme. It converts it to angiotensin 2, my raw system. Now, what does that mean? This was a situation where my blood pressure is low. And this is what the body was having to do to raise my blood pressure.
Some more salt?
It's due to the ability for the kidneys to help return sodium. But low blood pressure can be just as much of a problem as high blood pressure. When you have high blood pressure, you're put on different medications. Have you seen any commercials on TV that say, if you are currently taking or have previously taken an ACE inhibitor, do not take this medication? Have you seen any commercials that say that? Have you ever noticed that when you see commercials about medications, they throw a lot of terms out at you, but do you really know what they all mean? ACE inhibitor. There's a medication to inhibit this enzyme. If I inhibit this enzyme, I inhibit the entire raw system, which was to raise my blood pressure. So this would be another way to control blood pressure problems. It's a very focused type of medication to control blood pressure problems, and other medications are not very friendly when taking ACE inhibitors. So that's what that means, which is kind of cool. Our stomach and our intestines. Too many for me to even begin to get into because we covered a lot of that in Chapter 26. But there are at least 10 enteric hormones. Now, what do I mean by enteric?
Digestive.
That's only in my digestive system. Because in times of extreme severe stress, the digestive system shuts down, but we still need, in some way, for something to work with it, and it will then engage its enteric division. And it's being controlled by nothing except the connection between that division and the brain. It's called my gut-brain peptides. But it's only going to be put into motion, and when I say extreme stress, I mean extreme stress. Okay? So, it had all that stuff like cholecystokinin, ghrelin, gastrin. Do you guys remember some of those? PYY, peptide YY. Okay, your book will go into them, but it's, once again, it was in Chapter 26. Adipose tissue. One of the things that happens between the gut and the brain needs to know what are the fat stores of my body. And do I have enough or do I not have enough? And therefore, I need to affect the fat stores. Leptin is one of those that the adipose tissue releases. It communicates with the brain, and it can help to control appetite. They're doing research, I think, on this one, because they're thinking that it's a defective receptor for this chemical on the cells of the body in severely obese people. And they're overeating because it's not getting the message that the fat stores are okay in the body. So that is one that they're studying in association with obesity. Osseous tissue, bone tissue. Our osteoblast. Which cell is that? What is that cell doing? Because I have blast, I have sites, and I have clasts. What do blasts do?
Secrete.
Build up, secrete, lay down, okay, because that's what it's doing for the osseous tissue. It's actually secreting and laying down the hydroxyapatite. So the blast can secrete osteocalcin, a hormone, that will have an effect on the beta cells of the pancreas. This might play a part, they're working on this, in the deposition of fat into the fat cells and their effects upon type 2 diabetes. Because you have type 1 and type 2. And type 2 is usually due to your lifestyle. The placenta has a lot of functions in pregnancy. It helps with nutrition for the fetus, oxygenation, waste removal, secretes estrogen, progesterone, other hormones to help regulate the development of the fetus, and of course, mom's mammary glands. Because we're going to have to make sure that prolactin, because remember, for the most part, it's prolactin inhibiting hormone. So we're going to have to make sure that we actually get prolactin releasing at the time that it's needed during the woman's pregnancy. So those are our hormones. The glands that we get them from, the areas of the body we get them from. So what is it about their action? Once we get those chemicals, what do they do? We basically take hormones, okay, these chemicals, and put them into classes. We're either going to say that they are a steroid hormone, that they are monoamines, or peptides. Now, if something is derived, made from cholesterol, in the grand scheme of things, how do we tend to think of cholesterol?
It's negative.
Bad. Go to the doctor. They're like, oh, your cholesterol levels are too high. Do you have any idea what that means? None? When we take in our foodstuffs and foodstuffs are broken down, all right, one of the things that we hope will happen is that as they're broken down, these little fatty pieces and particles will kind of get wrapped in a little bit of membrane, and they'll get shuffled to the cells of the body, and the cells of the body will use them to basically make stuff, mostly parts of the membranes. If that product is too high in the blood, you got the high cholesterol. And you should be having those good and bad components of it, you know, supporting and all that other stuff. Under the conditions of the body for cholesterol, cholesterol, if you remember, is a component of the plasma membrane. It makes up the structure of the plasma membrane to give it some of the shape. And under normal conditions, it's okay. Usually the body takes it in, it uses it. We use it for different products. We're going to use it for the sex steroids, corticosteroids, and calcitriol. Those are the products that are considered steroid. All right? If we have something that is a monoamine. Mono means how many? One. What do you think of when you hear amine? Amino acid.